Hey, my name is Felipe and welcome to my channel. In this video I'm going to show you how to make an image classifier using YOLO V8 on your own custom data. I'm going to show you every single step of this process, from how to organize the data so it complies with YOLO V8, how to do the training in your local computer, and also from a Google Colab, how to validate the performance of the model you train, and finally how to take the image classifier in order to make new predictions. I'm going to show you the entire process. This is going to be an amazing tutorial, and now let's get started. So on today's tutorial I'm going to show you how to train an image classifier using YOLO V8 on your own custom dataset. So let's get started, and the first thing I'm going to do is to show you the data I am going to use in this tutorial, which is a weather related dataset. Let me show you the different categories we have, and let me show you all the different images, how they look like. We have 4 different categories and they are cloudy, rain, shine, and sunrise. Now let me show you each one of these categories. For example, the cloudy category, this is how the images look like. You can see that in each one of these images we have a sky which is completely cloudy, right? We have many different clouds for each one of these images. Now the sunrise category, it's basically many different pictures of sunrises. So this is how this category look like. And now for the shine category, we have a sky which is completely clear and with a super bright sun, right? You have the sun in each one of these images and it's super bright. And this is a rainy category, and you can see these are many different pictures of super rainy days. So this is basically the dataset I am going to use in this tutorial, but obviously you can apply absolutely everything I'm going to show you today to absolutely any type of dataset. You are going to be able to build any type of image classifier with everything I'm going to say in this tutorial. Now let me show you the structure you need for your data, because if you're going to train an image classifier or if you're going to use YOLO V8, yes, the data is super important, but you also need to structure, to give like a format to all of your data so it complies with the way YOLO V8 expects your data to be, right? YOLO V8 requires your data to be in a given format, in a given structure. So I'm going to show you exactly how to structure your file system so everything looks the way it should to train an image classifier using YOLO V8. So if I show you, I have a directory which is called weather dataset. This is going to be the root directory. You can call this directory whatever you want, but you need a directory which is going to be your root directory. And inside this directory you can see we have 2 different folders. One of them is called train and the other one is called val, and this is exactly where you're going to have your training dataset and your validation dataset, right? It's very important you name these directories exactly like this. One of them should be called train and the other one val. Now if I show you within the train directory, this is where we are going to have all 4 directories containing all the different images for all of our categories. Basically you need to have as many directories as categories you want to classify with your model. So in my case I want to classify an image into 4 different categories, and this is why I have 4 different directories, 4 different models. Each one of these directories is named as the category I want to classify my images in, right? One of them is called cloudy, the other one is called rain, then shine, and then sunrise, and these are the categories I want to classify all my images. And then within these directories, these folders, is where I have all my data. Within cloudy is where I have all my data related to the cloudy category, and so on, right? The same happens for the rain and the shine and the sunrise category. So this is basically the structure you need for your data, the structure you need for your file system in order to comply with what YOLO V8 is expecting for your data. And then if I go to the val folder, you can see I have exactly the same structure. I have 4 different directories and they are named under the categories I want to classify all my images. And then if I open these directories, it's exactly the same. You can see that I only have different images for that specific category. Now this is very important because from now on everything is going to be super straightforward. If you have created this structure for your file system, if your data is exactly in the structure I show you, then it's going to be super simple to train an image classifier using YOLO V8. So this is very important. Now I'm going to show you 3 different ways in which you can train an image classifier using YOLO V8. So let's start with the first way, which is using a Python script. We are going to make a very simple script in Python in order to train this model, and let me show you how to do it. So let's go to PyCharm. This is a PyCharm project I created for today's tutorial, and the first thing you should do if you want to work with YOLO V8 is to install a couple of dependencies, a couple of Python packages. These are two packages we are going to use in this tutorial. One of them is Ultralytics and the other one is NumPy. Ultralytics is very super important because this is exactly the library you need in order to import YOLO, in order to train this model using YOLO V8. So you definitely need these two packages. Now, in order to install these packages, this is how we are going to do it. I'm going to show you a way to install these packages, which is going to work with whatever your OS, right? If you are a Linux user, or if you are a Windows user, or if you use Mac, it doesn't matter, it's going to work anyway. So you need to go to File, then Settings, and then you have to select Python interpreter, right? This is the Python interpreter we are going to use. You can see that I'm using Python 3.8, and then you need to click on plus, and this is where you're going to find, you're going to search for the packages you want to install. In my case, I'm going to search for Ultralytics, and the version I'm going to use, let me copy the version first. It's this one, so I'm just going to File, Setting, then Ultralytics again, and then the version is this one. Okay, and then I click on install package. In my case, I have already installed this dependency, so nothing is going to happen on my computer, but please remember to do it on your computer, because otherwise you will not be able to use, or you're not going to be able to do anything of what we are going to be doing today. Now let's see NumPy, what's exactly the version we are going to use. We're going to use 1.24.2. So File, Settings, plus NumPy 1.24.2. So everything is okay. Now install package. This is like everything is okay. NumPy has been installed successfully. So now we are ready to continue. Once you have installed these two dependencies, these two packages, now you're ready to continue, and now you're ready to install your own image classifier using YOLO V8. So let's go to main. This is the file we are going to use in order to code everything we need in order to train this classifier. And let me show you exactly what's the code you need to type in order to do this training. I'm going to over here to the GitHub repository of YOLO V8, and I'm going to select the classification section, right? I'm going for the classification, and then here I'm going to click on classification docs. This is going to open a new file, a new URL, a new website, a new page, and this is exactly all the information we need in order to train this image classifier. I'm just going to scroll down, and I'm going to the train section, and this is what we're going to do. I'm going to copy and paste this line, which is the one in the middle, the one that says load a pre-trained model recommended for training. I'm just going to copy, and then I'm going back to PyCharm, and I'm just going to paste it. Obviously, we need to import YOLO, otherwise this is not going to work. So I'm going to say from Ultralytics import YOLO. And that's pretty much all. You can see now we are creating our model, or we are creating the object we are going to use as our model. And then I'm just going to copy and paste this last line, which is model.train. I'm going to paste it here, and then I'm going to make a few edits. I'm going to leave like this value. I'm going to leave the image size in 64, but then for the number of epochs, I'm going to set it in 1. Right? Because the first thing we're going to do is we're going to do a very dummy training in order to make sure everything works as expected, in order to make sure everything works properly. And once we are completely and 100% sure everything is okay, we are going to move forward with a more deeper training and with a more real training, right? But for now, let's just do the training for 1 epoch, and let's see how it goes. Then for data, this is where you're going to specify the absolute path to the data you are going to train this model with, right? In my case, it's going to be this weather dataset. So I'm just going to copy and paste the absolute path of this dataset, which is this. I'm going to copy this path, and I'm going to paste it here, right? This is the data I am going to use. Remember that you need to specify the absolute path to the root directory of your data. And remember, you need to structure your data into the exact format I already mentioned, right? Otherwise, this is not going to work. And that's everything we need in order to train this image classifier. So the only thing I'm going to do is to press play. I'm going to run this script. So let's see what happens. Remember, we are running this training we are doing this process for only one epoch because we need to make sure everything works properly, and once everything is working properly we are just going to edit this value and we're going to make this training for more epochs. But you can see everything seems to be working properly, so everything seems to be okay and everything seems to be completed and everything seems to be ready. So that's it. And you can see that the results have been saved here in runs classify train 12. So let me show you exactly where this directory, where this location is in my file system. If I go to the project, the PyCharm project I created into my file system, this is exactly the project I created. This is the file we are currently working in, the main.py file, and this is where my data is located. And this is where the runs directory, the runs folder will be located. This is where it will be created. You can see that within runs we have another directory which is called classify, and here is where you will have many folders for each one of your training processes. And you can see that in my case I have trained this classifier many different times while I was preparing this video, so there are many directories for me, but this is exactly the one which was just created, the train 12, right? Train 12. This is exactly the directory which was just created, and if I open this directory you can see we have another directory and then we have two files. I'm going to explain what exactly all these different files and all these different folders are and exactly what's the information we have in all these files, but I'm going to do it later on this tutorial when we are validating this training process, right? For now, just remember all the results will be saved here, will be saved within this folder, within the runs folder, and then within classify, and then a new directory, a new folder will be created for the training process you have just executed, right? This is something you need to remember for now, but later on in this tutorial I'm going to show you exactly how you can validate the training using the information that's within this directory. But for now, let's continue. I'm going to show you now a different way in which you can train this image classifier using YOLO V8. I'm going to show you how to do it using the command line, using this utility. And this is actually like a very straightforward way to do this training. Let me show you. You can see that we have 3 different examples. I'm just going to select this one. I'm going to copy and paste this instruction, this line, and I'm going to show you how I do it. I'm just going to paste it here, and you can see that we have many different parameters, right? In the first word is YOLO, this is the utility we are going to execute. Then classify, this is the task we are going to execute. We are going to train an image classifier, and then we are going to train it. So we have another keyword which is train, and then we have these arguments: data, model, and epochs, and also image size. I'm going to do exactly the same with image size. I'm just going to leave this value in 64, but then I'm going to edit all the other values. Or actually I'm going to edit number of epochs, and I'm also going to edit data. For the number of epochs, let's do something similar. I'm just going to do it for one epoch, so we make sure everything runs smoothly and everything runs properly, and then we can do like a more serious training, a more real training for more epochs. This is exactly the model I'm going to use, so I'm not going to edit this keyword either, and then I'm going to edit this argument, and I'm just going to say this is the absolute path to my data. So this is going to be exactly the same as I have over here. Something like this. Okay, and that's pretty much all. The only thing I need to do now, I'm going to copy and paste this sentence, and I'm just going to the terminal, and I'm going to do something like this, right? I'm just copying. I have just copy and paste that sentence, and you can see that that's all we need to do in order to train this image classifier using YOLO V8. You can see that the model, the training process has started, and everything is running super smoothly. So everything is going super well. That's all, right? That's a very quick way and a very straightforward way to do this training. And you can see that the training has just been completed, and this is exactly where the results have been saved to runs classifier train 13. So everything is completed, everything is ready. You can see how simple, how fast it is to train an image classifier just by running this command. Now I'm going to show you another way to do this training, which is using a Google Colab. We are going to use a Jupyter Notebook. We are going to use a notebook in a Google Colab in order to train this model. And this is also like a very good way to do it. So let me show you how to do it. So basically you need to go to Google Drive, you need to go to your Google Drive, you need to select new, then more, Google Collaboratory, and this is going to open a new notebook. This is going to open a new notebook in Google Colab, and this is exactly what you need to do in order to use this notebook to train YOLO V8. Now I'm going to show you a notebook I have already created in order to train this model, which is this one. It's called train.ipynb. And obviously I'm going to give you exactly this notebook in the GitHub repository of today's video, of today's tutorial, so you can just use this notebook if you want. Now I'm going to show you all these different cells, everything that's already written on this notebook, so you understand how exactly to use it and how it works and what exactly you are doing at each step. So let's start with the first step. Another thing you need to do if you want to train this image classifier is to upload all the data with all the images and with all your categories into Google Drive, obviously. For example, in my case, this is where I have my weather dataset. You can see that this directory is exactly the same directory I have over here. Weather dataset. Within weather dataset, there are two directories which are train and ball. If I open this directory, you can see we also have train and ball. So this is exactly the same data as in my local computer. Now this is something very important, because remember to do it, because you need the data in your Google Drive in order to train this model using a Google Colab. This is a very important step. Please remember to upload your data into Google Drive. Now, once your data is in Google Drive, then you need to be able to access your data from the Google Colab. And in order to do that, you need to execute this cell. If I click enter, you can see that now I'm going to be asked if I want to connect Google Colab with Google Drive. And the only thing I need to do is to say I accept. There you can see that it's requesting for my permission. I say connect to Google Drive. And then I select my account, and then basically is to go scroll down to the bottom of this page and to click allow, and this is going to allow Google Colab to access all the data you have in your Google Drive. So this is a very important step. Now, something that's very important is that you need to be able to access your data, so you need to know where your data is located in the Google Drive, right? You need to know exactly what's the path, what's the location of your data in Google Drive. In my case, let me show you my Google Drive. You can see that my data is located into a directory. This is my root directory, which is my drive. Then I have another directory which is called Computer Vision Engineer. Then another directory which is Image Classification, YOLO V8, and then data, and then this is where my weather dataset is located. In your case, it's going to be different. Obviously, it depends on where exactly you have uploaded your data. So something you may want to do is just to click this ls. You can say something like ls, and then you say something like content, my G drive, my drive, right? You execute this command, and if I execute this command, you're going to see a very long list of files, which are basically all the files which are in my root directory in Google Drive. And for example, this is where I have the directory which is called Computer Vision Engineer, and if I do ls, you're going to see all these different directories. If I say something like Image Classification, YOLO V8, then this is data train.ipynb, which is exactly this notebook. And then if I say data, this is exactly where the weather dataset is located, right? So do something like that, because you definitely need to know what is the path of your data in Google Colab, right? You definitely need to do it in order to continue to the next step. This is very important, because if you haven't set your data properly, if your data location is not set properly, then YOLO V8 will not be able to train your model. This is very important. So in my case, this is exactly where the data, the weather dataset is located, right? This is the path to the weather dataset. So this is the cell I am going to execute, that this is the value I'm going to save in this value, in data directory, in data dir. Now I'm going to continue. Then we need to pip install Ultralytics, which is the library we need in order to train this model, in order to use YOLO V8. Now the only thing you need to do is to execute this cell, and everything will run super smoothly. You can see that we have already completed this process. Now I'm going to continue, and the only thing we need to do now is to execute this cell. And you can see that the code we have in this cell is very similar to the code we have over here, right? Basically, we are running a Python script from a Google Colab. That's all we're doing. So you can see we are importing OS, and also we are importing the YOLO library. We are importing from UltraLinux, we are importing YOLO, and then we are doing exactly the same as we are doing before. And this is where we are using the data directory, the data dir variable we have defined over here, right? So this is why it's very important you set this variable properly. So the only thing I'm going to do exactly the same as before. I'm just going to do this training for only one epoch, so we make sure everything's okay. I'm going to press enter, and that should be it in order to do all this training. The first time you execute this training, it may take a little longer because you are downloading all the weights and you are downloading the models and everything, but after that everything should be much quicker. Okay, so you can see that now the training process is in progress. Everything is going super well, and from now on the only thing we need to do is to edit the number of epochs, so we do like a more deeper training. But I will say everything is working super properly. So now let's move to the other cell, so I show you what exactly you need to do once everything is completed. Once everything is completed, the only thing you need to do is to run this cell. So you are going to copy all your results which were saved on this directory. You're going to copy everything on your Google Drive, right? Because remember, you are working on a Google Colab, you're working on an environment which is your Google Colab environment. If you don't do something like this, it's going to be super hard for you to get the data you have just trained, right? To get your results, to get your model, your weights. It's going to be super hard because everything is located in your Google Colab environment. And long story short, it's going to be much simpler and much better if you just do something like this and you just copy everything, all the results which were saved in this directory into your Google Drive. It's going to be much better because it's going to be much easier to download the weights, to download the results, and so on. So now I'm just going to wait a couple of minutes so everything is completed over here, and then I can show you how to copy the results into your Google Drive. Okay, now the training process has been completed, and you can see that the results have been saved into runs, classify, train. So these have very similar output to the one we just noticed when we were training on our local environment. Now, the only thing we need to do is to copy everything into our Google Drive, so everything is much simpler if we want to download these results or to do whatever we want. So the only thing I'm going to do is to run this cell, and everything will be copied into this directory, which is the same directory where I have my data and where I have my Google Colab, right? Now you can see that everything has been copied already. This is the directory I have just copied. This is the time, this is the current time. So this is the result of the cell I have just executed. And if I go to runs, classify, train, you can see that these are all the results we have generated. This is the CSV file containing many different results, which I'm going to show you in a few minutes, and these are the weights and so on. So from now on, if we want to get this data or if we want to analyze this data, the only thing we need to do is to select runs, and then we just need to click download, and this is going to download all this directory into your local drive, right? You can see everything is being zipping and once everything is zipped, this directory will be downloaded into my local computer, and you can see that this directory has just been downloaded, so everything is working just fine. Now, this is pretty much all in order to show you 3 different ways in which you can train an image classifier using YOLO V8. And now let's do the deeper training, right? I'm just going to take this script and I'm going to edit the number of epochs, so we do this training for something like 20 epochs. I have already been doing some tests, and 20 epochs is just enough for this dataset, for the dataset I am using in this tutorial, so 20 will be just fine. Now, the only thing we need to do is to click on run. I'm just going to run this script as it is, and everything will be exactly the same as before. Everything will be exactly the same, right? We just need to wait until this process is completed. We don't need to do anything from now on, but this process will be executed for 20 epochs. So the only thing I'm going to do is to wait until this process is completed, and once everything is completed, we are going to validate this training process. I'm going to show you how to analyze if all this process was done successfully or not, if you have successfully trained a good image classifier or not. So I'm just going to pause the recording here, and I'm going to fast forward until this is completed. Okay, so the training process has been completed, and now let me show you all the results which were saved here into runs, classify, and train 14. Now let me show you this directory, this folder in my local computer. If I go to runs, classify, and then train 14, this is where all the results have been saved, and this is everything we are going to analyze now. Now we are going to decide if the model we have trained is a good model or not. We are going to decide if this is a model we can use or not. So you can see that there are two files, arg.yaml, results.csv, and another directory called weights. Let's start by args.yaml. If I open this file, you can see that this is something like a config file, and this is exactly the entire configuration file which we have just used in order to train this model. This is very important because this is a super comprehensive list of all the hyperparameters we have used in order to train this model. And for example, the only parameters we have specified are image size, number of epochs, and then data, the location of the data we have just used. And you can see that we have a keyword which is data, then epochs, then image size, and then we have many other keywords as well. This is very important because these are absolutely all the keywords we have used. We have used all these default values which were set for all these different keywords, and this is important in case we want to train a new model and we want to make some changes into some of these hyperparameters. Now let me show you the other file, which is the results.csv file. I will say this is much more important. This is like the file containing all the information we need in order to decide if this is a good model or not. And you can see that we have many different rows, each row for one of our training epochs, right? We have trained this model for 20 epochs, and you can see that we have 20 rows for each one of these epochs. And for each one of these rows, we have all this different information, and we are going to focus on these three values, on the training loss, the accuracy, this is the accuracy on the validation set, and then also the validation loss, right? These are the three keywords in which we are going to focus on this tutorial in order to validate this model. And I'm going to give you like a very quick tip, like a very quick way in order to analyze this training process, which is make sure the training loss and the validation loss are going down through this training process, and also make sure the accuracy goes up. And I know you're thinking, hey, this is a very simple way to analyze this process, Felipe. Yeah, I agree with you. This is a very simple way, but at the same time, it's very robust. This is like a very simple, but at the same time, very powerful way to decide if you have a good model or not. Now, we can analyze all these numbers, but I think it's going to be much better, and it's going to be much prettier if we make a plot with all these numbers, right? Because we have epochs in this column, in this coordinate, and we also have all these different values, and we can definitely plot these values across all these different epochs. So let me show you a Python file I have created, and this is exactly what this Python file does. This file is called plot metrics, and if I open this file, you can see that it basically we need to set a path to our results.csv file. In our case, I'm going to set it to train 14. And you can see that this is runs, classify, train 14, and then results.csv. And then this is only like some logic, some very simple logic to take all the data from this results.csv file and to do some plots with it, right? That's all we're doing. We're just taking the data and doing some plots. And this file will be available in the GitHub repository of this project, of this tutorial. So you can definitely take this file and you can just use it to plot your functions as well. All I'm going to do now is just press play, and you can see that if we wait only a few seconds, we get all these two plots, right? And this is all the information in our CSV file, right? Everything I show you over here, it's summarized on these two plots. So this is exactly what I mean with make sure your loss is going down. This is our loss in the training set and in the validation set. In the training set, we are plotting the loss in blue, and in the validation set is red. And you can see that in both cases the loss is going down, right? Which is exactly what we expect. It's exactly what we want. Now, this is a very simple way to analyze this process, but trust me, this is also a very powerful way, right? This is something that's very healthy. Something that looks like this is very healthy. And then for this other plot, which is how the validation accuracy evolves through this training process, you can see that the validation accuracy goes up when we increase the number of epochs, right? You can see that starting from the 10th epoch or so, everything starts to be like somehow idle, right? We are not really gaining a lot of accuracy from here, but we are not losing accuracy either, right? We are just in something like a plateau. And this is exactly how a validation accuracy plot should look like, right? We are starting from a very low value and then we are just increasing our accuracy until we reach a very high value of accuracy, right? This is like a very healthy training process. Now, obviously, we could make this process even better if we just if we just change some of these parameters, and if we do like a more customized training. I'm sure we will be able to have a better model, right? Because remember, we are using all the default values. So as it usually goes, if we make like a more customized training and we have different and we try different AP parameters and so on, we should be able to get like a better model. But obviously we are not going to do it in this tutorial because I just want to show you like the end-to-end on how to train this image classifier. But remember, you could do it even better than this if you make like a more custom model. So this is pretty much all for analyzing these plots, which are the validation accuracy and the loss function in order to validate your training. And then it's like the this directory, which is the weights directory. You can see that this directory is called weights, and this is exactly where the models will be saved. This is very important because you have trained a model and now obviously you want this model in order to use it in your images, in your data. And this is exactly where you're going to find this model. And you can see that you have two different files. One of them is called last.pt and the other one is called best.pt. Now let me explain exactly what these two files are and exactly what they mean. So remember how this training process works, right? Remember that you have a model, you have a deep learning model, which is comprised of many different weights. And the way it goes is that at the end of every epoch, right? At the end of the first epoch, of the second epoch, of the third epoch, and so on, you are updating the weights of your model. You are updating the weights of your architecture, of your deep learning model. So the way it works is that at the end of every epoch you have a model available, which is a model you have trained so far with all the process you have followed so far. So last.pt means that you are taking the model which was the result of the last epoch of your training process, right? Remember, at the end of absolutely every single epoch, you have a model available, you have a model which you can definitely use if you want to in order to produce your inferences and so on. So last.pt only means that you are taking the last model, the model which was produced at the end of your training process, at the end of the last epoch in your training process. So at the end of the 20th epoch in our training process, we are producing this model which is last.pt. But you may wonder, hey Felipe, yeah, it's great because at the end of our training process our accuracy is something like a 93%, right? A 93% it's a very good accuracy. But if we take the accuracy, if we take the model at the end of the 16th epoch, for example, our accuracy it's higher, it's a 94.9%. Maybe it makes more sense to take that model instead, right? Because we have an even better accuracy, we have an even higher accuracy. And if you ask me something like that, I would say, yeah, you're perfectly right. You're super right. That's a very valid argument. And that's exactly what the best.pt model is, right? We are saving the weights of the best model in our entire training process. So if we look at our data, the best model in our training process is this one, if I'm not mistaken, right? It's the model we produced at the end of the 16th epoch, and our accuracy or validation accuracy was 94.9%. So this is definitely higher than the accuracy we got at the end of this training process, which was a 93.5%. And if we will take the best model we have produced in the entire process, in the entire training process, then we will definitely need to take this model. So this is exactly what best.pt represents. Is the best training, the best model you have trained in your training process. And if you ask me, what I usually do is taking the model which was produced at the end of this training process, right? What I usually do is taking the last.pt file, because I consider that this is a model we have produced at the end of the training process. In this model, we are summarizing much more information, right? Because we are considering much more data, we are considering much more everything. In all this training process, many things are going on, many things are going on. And remember, there's a lot of randomness in this training process. So me personally, I consider that if I take the model which was trained at the end of this process, is a much better option than if I choose another one. If I choose like the best model or the model which I got the highest accuracy, but it's not the last model. That's what I usually do. I usually take the last model which was produced at the end of the training process. But if you want to take the best model, if you want to take the best.pt, it also makes sense, because you are taking the model which produced the highest accuracy, right? So you can do either one of them, and I think it's a very good option. That's why you have these two files, because you can use one of them or you can use the other one. And I will say that making like a very like the best decision on which model to use depends on many different variables, depends on many different things, depends on your data, depends on your problem, depends on your use case, depends on your training process, depends on many different things, which is the best option, right? So remember, you have these two models, and it's all up to you. It's all up to your specific project, and it's all up to your preferences which model you want to use, right? If the best model which you have produced through the entire training process, or if you want to use the last model, the model which you have produced at the end of your training process. So now let's go back to PyCharm, because now it's time to make our inferences. Now it's time to predict new samples, right? And we are going to input an image, and we're going to use our image classifier in order to predict which category this image belongs to. So let me show you how to do it. I'm going to import from Ultralytics, import YOLO. And then let's go back to this page, because now we are going to move to the predict section. And the only thing I'm going to do is to copy this sentence, going to paste it here, and then I'm going to specify the path, the absolute path to the model which we have trained, right? We don't really need to make it like the absolute path. We can use the relative path. So I'm going to do something like this, right? Sorry, something like this. So this is the path to the model we have just trained, right? This is the last model which we produce at the end of this training process, and this is the model I'm going to use in order to show you how this works. And now let's copy this additional sentence, which is results equal model and the model path, the image path, right? You can see that you can use an image in your local computer, in your file system, or you can also use something like an URL. For example, in this case, in this example, which is in the YOLO V8 website, you can see that the example is using an URL, and this is also going to work. So in my case, I'm going to use an image in my local computer. I'm going to use one of the images I used for training, because I only want to show you how this works, but obviously you can use whatever data, whatever image you want. So this is the image I am going to use. I'm just going to inference this image, right? Which is the first image in my sunrise category data. So this is going to be something like sunrise1.jpg. And this is pretty much all. So these are the results. The first thing I'm going to do is just trying to run this code, and let's see what happens. Everything should run smoothly, but this is where we're going to see if we have any error or something like that. We may need to wait a couple of seconds and everything seems to be working fine because we didn't get any error. So what I'm going to do now is I'm going to print results because I want to show you a couple of things. So this is the entire information we are getting when we are printing results, right? You can see that this is a lot of information. We have these probabilities, which is the inferences we are making. This is exactly the result of applying our image classifier, and then we have a lot of information. Another object or another result which is very important is this one, which are the names of the categories we have just trained our image classifier on, right? You can see that this is cloudy, rain, shine, sunrise, and also you can see that we have different integer values for each one of these categories. So this is something like a dictionary, because we are going to have a result from applying our image classifier, and then with this result, which is going to be an integer, we are going to call this dictionary, we're going to call this object, because we want to know exactly what's the name of the category we have just inferenced, right? So this is how we're going to do it. I'm going to call another variable which is going to be names, something like names dictionary, names dict, and this is results 0 because results is a list. In this case, we only want to access the first element because we are only predicting an individual image, so this is the element we want, and then we are going to call dot names, and that's pretty much all. Then I'm going to define another variable which is props, and this is results 0.props, and this is the probability vector of all the different categories we are trying to classify, right? So we are going to have a length 4 array with the probabilities of the different classes we are classifying, right? So let me show you how props looks like. I'm going to print props, and I'm going to do something else. I'm going to say to list, so we make this object into a list. We are using YOLO, which is based on PyTorch, so if we don't do this, if we don't call this method, we will be working with a torch object, right, with a tensor, so we don't really want to do that, so that's why I'm doing this to list. Now I'm going to print props, so I show you how it looks like, and I show you how to continue from here. Okay, you can see that this is a result we got from printing props, and you can see that this is a list with 4 elements, 1, 2, 3, and 4, and each one of these elements are the probabilities of this image to be one of these categories, right? Let's print the names too, so we have all the information in our screen. I want to show you something, so I'm going to print. Sorry, this wasn't names, this was names dict. And now let's wait a couple of seconds. I want to show you not only the probabilities but also the class names, so it's a little more clear what exactly I'm going to show you now. So this means that this number is the probability for this image to be cloudy, right? This other number is the probability for this image to be rain. This other number is the probability to be shine, and then this last number is the probability to be sunrise. And you can see by the values that we are definitely classifying this image as sunrise, right? Because this is almost a 1. This is almost like a super confident and absolutely confident classification. So this is exactly the category we are classifying for this image, and this is how to make sense of this information. So what I'm going to do now is to print names dict, and then I'm going to call mp.argument argmax, and then I'm going to input the probability list I just showed you, and obviously I need to import numpy as mp, otherwise it's not going to work. And basically what we are doing here is that we are looking at this list, the one containing all of our probabilities. We are taking a look at the maximum number, which in this case is this one, and we are taking the index of this maximum number. So in this case, this is the first element, so this is the index 0, this is 1, this is 2, and this is 3, right? So from this From calling np.argmax_props, we are getting 3, and then we are calling the third element of the namestick object. So we go here and we see that 3 belongs to the sunrise category. And if we look at this image again, we are going to see we are in fact plotting a sunrise. Let me show you. So everything seems to be working fine, and this is going to be all for today. This is exactly how you can train an image classifier using YOLO V8 in your own custom data, and this is going to be all for this tutorial. So this is going to be all for today. If you enjoyed this video, remember to click the like button, and also remember to subscribe to my channel. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of projects I make in this channel. So this is going to be all for today, and see you on my next video.